Hi guys, welcome back to Coders Arcade and welcome to our today's DSA placement series. We are gonna be live every day, like every day I come live here and I do DSA placement series. So today is the very first day where we are actually going to start a data structure and understand how it works. Yesterday in our yesterday's class we have understood about a 1D array, 2-dimensional array, and we have understood about array pointers. We have already done pointers before, we have already done storage classes before, we have already done all the basic things like data pointers and dynamic memory allocations. All of that we have already done. Today is going to be the 5th session of DSA placement live, and we are gonna do that. Let us start without any interruption, guys. And already our first comment has already come. Sir, when is Java classes? So Java classes, we are coming live about Java every Saturday. But tell us in the comment, guys, that if you want Java every day also, we can do live Java every day as well, like how we are doing DSA. We can do that also. We can run a small crash course maybe, or a proper course on Java every day coming live. We can do that also. So if you want that, tell us more about that into the chat and we will be continuing. So now already let's start. I hope so that everyone is able to understand what I'm trying to say. Till now we have done pointers, dynamic memory allocation. We have done all of that in one place. 5th session today. Let us start with stacks. So in today's class, let us start with stacks. Alright, so let's start. Today we are gonna learn about stacks. Today's class only we are gonna talk about stack data structure. So as soon as this stack gets over, I will finish up the class. Let's talk about this. What exactly is a stack? What is a stack data structure? So stack data structure is first thing first, it is a data structure. Okay, it is a data structure. I have already explained you what is a data structure. It is a structure which allows us to organize data at one single place, in this case in a type of a stack formation. What exactly is this stack formation? Talking about a stack, your stack, you think about a stack form of data. What exactly we are talking about? Stack means that kind of data which happens to be kept one upon each other like this. So for example, I have a stack of books. So there are multiple books kept upon each other. This is one stack. Or maybe you can say stack of plates. In your kitchen you see stack of plates you have, or maybe you have some stack of some random item. That is how your stack works or looks. So basically, if I take any example, if I say basically any example, it will be data kept one upon each other like that. That will be your stack. Okay. Now speaking of a stack, we have understood this basics, that the data is kept one upon each other. Okay. The concept of stack happens to be like this, where I can create a container. And this container, right now it is an empty container right now, and here you see that when I put anything inside it, it goes very at the down of that particular data structure. In this case it goes right here. My first element is now filled up. Okay, now my first element is filled up. This is gonna be my first element. Okay, I'll mark it like this. This is my first element. Okay, I'll mark it with the same color first. Then I said I am adding more elements. So one more element got added just above it like so, and this element is gonna be the second element. You see the stack, in this kind of a stack, what happens is that this data, this green data is kept upon this red data, and when this happens, this is a stack formation where our data is being placed one upon each other. I hope so that this is very much clear. There is one comment now. Learning MERN plus DSA, लगता है जिंदगी खत्म होने वाली है. तो ऐसा नहीं है, DSA में बहुत कुछ है पढ़ने के लिए. And if you are looking for MERN is another language that you are doing DSA in. So, well, that's nice. Anyways, let's continue. So now we are talking about the stack. Here in this case, the stack is gonna be, this is stack formation where the data is being kept one upon each other like this. So if I add more and more data, let's say this is one more data, okay, this is our third data, okay, that data is being filled just upon that second data. So what happens is that this is a stack formation. This is how stacks they look like. So ultimately we are storing data upon each other. Okay, this is your stack data structure. We'll come back to this later on very soon. Pausing this right now, understanding the real world example. If we talk about in the real world example, what can be a real world example? What is going to be the real world example of a stack? As I told, in real life, a stack of books or stack of plates is going to be a real world example, but where in technical, in technology, in real time, in software development, where it can be used. A good example is going to be your Spotify app. You remember Spotify app? Okay, you remember Spotify? Everyone knows about Spotify, I hope so, right? In Spotify app, you have a ability to create a playlist. I hope so that everyone have seen that, right? How that playlist can be created. Well, you can implement a data structure like a stack data structure, and you can use that stack data structure to make or develop that kind of a data structure. In this case, you can say that Spotify playlist can be a stack data structure where we are storing all our songs one upon each other in a proper way. This I have already explained you in my very first session of DSA. What is DSA? What are the real world implementations of DSA? There I have taken a lot of examples, different examples, which will explain you more into depth. So if you haven't watched that session also, I would give the link of that session also. After just this session ends, automatically that session will start over. But basic example is going to be this. This is a real world example in this case. So this is how your stack will look like. Coming back to our point, the type of data structure gives us the ability of allowing us to store the data in one upon each other, that you have understood. But now what I am saying is that there is a very important concept that gets born out of this stack data structure, and the concept of first in, last out, or the reverse of it, last in, first out. You can say FILO or LIFO. These two things can be asked in interviews, and this is a very important concept. Many places you will use these concepts. How? Where? Just a small reference that I'll give. In your trees data structure, when you will do trees, in your trees, when you do BFS, breadth first search traversal, there you will be using the concept of philo or LIFO. I hope so that I am able to explain you what I am trying to say. Later on we will see this, but learning the concept of first in first out, first in last out, or last in first out is very important, because this can be used in many different places. I hope so that this is very much clear. Okay. Next, in this case, FILO stands for first in, last out, which is true in this case. The element which went first will come out at the last. Why? Because it is closed from beneath. I hope so that this is very much clear. It is closed from beneath. So you cannot take it out from the down. From the bottom you cannot take it out. If you want to take it out, you have to take it out from the top of that particular data structure which is opened from one side. Whichever it is opened from that side will come. So in that case, if anything which goes inside at the last will come out first. Hence, you create the opposite of it. That is last in, first out, LIFO. This is gonna be last in, this is gonna be first out. So you say philo or you say LIFO, it is gonna be the same. I hope so that this theory part is very, very much clear. Understood? This is gonna be your stack data structure. This is how it looks like. Later on, you will learn about queues data structure also. The difference is that queue is open from both the sides, but stack is open from only one side. I hope so that this is very much clear. Let's continue on to this and let's see it more. Speaking of stack data structure, we have to understand this, that in stacks there can be multiple things, multiple operations that can be performed. In this case, a stack data structure allows you to do the very first operation and very common operation, pop. I'll start from push, then pop, then the third. These two operations are very, very important, and these are something which you will be using every time. The third operation is gonna be top. This is gonna return you the topmost element or the element which is going to get deleted next or coming next. Then comes your, you can write then now anything in this case, you can say empty to check it is empty or not. These are the four functions which we will be doing a lot of time. Okay. So in this case, this is gonna happen. Okay. Speaking of this, one more thing. In future, we will be talking about STL. This stands for Standard Template Library. You will be learning about stacks there also. So stacks will be there inside your STL as well. But we don't have to get confused, guys. STL, if I talk about STL, STL is just a predefined library which is available for you to use in C++. This is not available in C or Java. This is the standard feature of C++, which is your STL, Standard Template Library. Now, this allows many different data structures, inbuilt forms also. So in this case, what stack we are learning today is gonna be the user defined stack. This is gonna be what? User defined stack. User defined stack. But when you will learn a stack again in future, we will be talking about inbuilt stack. Inbuilt stack. Okay. So in this case, what happens is that today we are learning about user defined stack. Inbuilt stack we'll learn about later on when we'll talk about STL, our standard template library. This you have to remember, okay? Everything is same. Here today we are gonna implement the whole concept of stack from the beginning, from the scratch. But in the inbuilt version, you will never do that. You will just directly use it by just including the stack into your program. As simple as that. But let's continue with our user defined stack. The very first thing first, what are the requirements that you need to do in creating this program for stack? You need some container which allows you to implement the concept of first in last out or last in first out, correct? And if you want to do that, then you need to have a basic container first. As the basic container, I can use an array. I can use a array. Very simple. Well, you can implement stack using arrays also. You can implement a stack using other data structures also, like linked list also. You can create a stack using even a tree also. But the thing is that we have not done that yet. So we will take that later on in future. But right now, yesterday's class only we have done arrays and we know about how arrays work. So today, in today's class, we will be implementing the stack using the arrays. And we are going to use array pointers as we have discussed about that in our yesterday's session. So if you have missed that session, please go ahead and watch that session as well. Session number 4, 1D array, 2-dimensional array and pointer array with call by value and call by reference. I have already explained this in my session 4. So now let's use that in today's lecture and understand how we can implement the stack data structure using array and array pointers in this case. Alright. So in this case, first we will be using an array. I am creating an array. So there you go. Guys, now we are gonna convert this array into a stack. Let me just draw it properly. So I'm gonna use this concept. You see how? You see this, everyone see this now. Very important concept. This is gonna be your array. Let's say I am gonna create this array. This is gonna be our array. Okay. Now, in this array, I want to make it look like a stack. And stack says the concept should implement first in, last out. Okay. This is what the concept says. And I want to do that. So guys, how will I make this array look like a stack? Today I am going to tell you a very easy trick which allows you to implement this FILO or LIFO, whatever. This is your array, and if I want to make this first in last out, then what will I do? I will start by taking a extra one variable called as top. I have taken a variable called as top. Okay. Right now, initially, I am gonna take this top as -1. Okay. Just remember, I have taken a variable called as top, and I have said that right now this top is -1. According to the indexes, this is our 0th index, 1st index, 2nd index, 3rd index, 4th index, 5th index, 6th index and 7th index. I said that the top variable starts from -1, means initially there is nothing in this array. What I will do is, I will start by doing the very first thing, push. I said push 5, push of 5, means I have this 5, now you have to push. So what I will do is, I will say that top variable, you plus plus, top variable u plus plus, and 5 is entered. Okay. Top plus plus and ARR of I is equals to ARR of top is equals to x. How the code will be looking like, I will be explaining you. Just wait and understand the logic first. Okay. I said top was minus 1. So, when top was minus 1, nothing was there. And when I said push 5, I said top plus plus and say 5. You know how array notation works? Array notation works like this. If the name of this array is ARR, if this is ARR, then ARR of top, right now when top happens to be plus plus, top is 0, so ARR of 0 equals to the value. This logic we are implementing. Simple. Before that, initially top will be at minus 1. Now I am saying top plus plus and ARR of top equals to val, so this way I will be able to do the push operation. You want more push operations to perform? Second, I will say push 10. Push 10 I said. So again top plus plus ARR of top equals to val. So in this case what happens is that top plus plus and ARR of top is equals to val, which is 10 here. So this way I have added 2 elements. I have pushed 2 elements inside this array. I hope so that this is very much clear. And whenever I will say push, what will happen is that it will keep on adding more and more elements. So I said push again, and I said let us say 15 I want to push. So I said 15 I want to push. So what will happen? First again top plus plus, I said top plus plus, and I said ARR of top is equals to val. So 15 came here. Yes, we can do that. ARR of plus plus top also we can use that directly. Okay. So in this case, this is the thing. Yes, we can do that. Okay. Next, in this case, if I want to do next operation, pop. How we will do? I will say top minus minus. I will say top minus minus. So in this case, I said top, you go back, and when I said top, you go back, this element gets deleted. How this element gets deleted? Technically speaking, this element will not get deleted, but that element is now hidden, in this case gone. But what you can do is you can deallocate the memory and then you can move top to minus minus in this case. Easy. So in this case what happens is that I can just say top minus minus. So when top, what exactly is top? Ultimately why we are using top? Top is a variable which shows the topmost element of the stack. So in this case what I have explained, that if this is a stack, then the topmost element is gonna be this, the topmost element. Top is the latest element in this case. So if I say top minus minus, that means that element is gone. So the next top is gonna be the topmost element. This is how you are gonna do this. Okay. Now let's come back to our concept. And in this case I have said push, push, push and pop. I want to say again pop. Now don't forget to check for the conditions, guys. Before pushing, you will have to check one condition. If top, if top is equals to n minus 1, or the size in this case for the array. This is the n minus 1. That means if top is already at n minus 1, then what it is stack overflown. Stack overflown means it is already full, so you cannot enter any more elements in this case. Okay. In push condition, your overflow condition is gonna be if top is gonna be equals to n minus 1 or the last element. Then you cannot push. Remember. Then you will say top plus plus. So if else, if that is the case, else top plus plus and then error of top equals to val. Understood? Next, in pop condition there is underflow condition also. So if I say pop, in this case what happens is that you can check for one more condition in this case. If top is equals to minus 1. See, if top is minus 1, in that case it is simple that it is underflown. Then you cannot do pop. If top is already here, then there are no elements already to pop. So in that case you cannot pop. So this is gonna be your underflow condition. I hope so that this is very much clear. Okay. So these are some bonus conditions that you should always remember to write. Don't forget this. Okay. So if I say one more pop, again I said one more pop. In this case what will happen? Top minus minus will happen and the top will move backwards and the element will get deleted in this case. So in this case now this is gonna be it. I hope so that you have understood this really well. This is how you will implement first in last out concept of array. Using array you can create a stack like this. Very easy, very simple. This is how you are going to do it. Now speaking of how you will code for it, we are going to code. Before I code, let me explain you just the essentials which are required for you to code. Number one, I will be using object oriented programming, which makes our life much more easier. I can use object oriented programming and I can use an array pointer to dynamically allocate the array the memory to an array using a pointer, and then I can directly use that array and do the same things, create multiple functions like push, pop, top, empty inside that. So I can have a class called as stack, and inside this class stack the attribute of this stack can be two. One is gonna be the array pointer, another is gonna be the top variable, and when we have this top variable I can use the constructor of this class called as, let's say, stack. This is gonna be the constructor of the class, and in the constructor of the class I can just initialize the, or I can just allocate the memory to the array in this case. I hope so that this is very much clear. Later on inside this class stack I can create functions like void push, void pop, and so on. Top, int top. In this case I will create int top because top is going to return the topmost value, and in this case void empty. Not void empty but bool empty, which is going to just return me true or false. Okay. These are the variables, these are the functions which we are going to create. I hope so that this is very much clear. Alright, let us move on to our programming part and understand how this is going to be done. This is the program that we did yesterday for array pointers. Now I am going to remove this and I am going to write everything from the beginning. Let us start from the beginning. I hope so that this is very much clear. I am going to increase the font size a little bit, starting from class stack. In this case I will start by creating a class called as stack. In this case what I will do is I will have two parameters, two attributes of this class, namely an array which array pointer, which I'll be using it for dynamically allocating the memory to the array and creating the array used for stack, and then I will create a top variable which will allow us to have the topmost element. Okay, let's do that. So in this case, I take a pointer called as int star arr. I have taken a variable pointer int star arr. Then I have said int top. So there are two things that I have taken: a pointer to an array, and I have taken a top variable. Using the constructor of the class, I can initialize both of them. Right? So I can say in the public section of the class, you see, maintaining the abstraction and encapsulation of the class, we are making sure that the pointer and the top variable are secured. Okay. So I can write my public section of the class from here. In this case, I'm going to say stack, and this is going to be our constructor. Constructor S should be capital. Okay. All right. So now I'm going to say here arr equals to, I'm going to allocate the memory dynamically, and to do that I'll say arr equals to, I'm going to use the new keyword. Remember, on the first day I've taught how to use new keyword. Well, I'm going to use that now. I'll say new, and I'll give the type int, and in the square brackets I can give a size. All right. Now the size is not given here, it's not mentioned. So what I'll do, I'll write a macro substitution preprocessor directive called as hash define, where I can just define these n before only, let's say 100. So I can allocate the memory like this using a macro substitution preprocessor directive. I hope so that this is very much clear to all of you what I have done here. Okay. Now the next part, what I'm going to do is initializing top 2 equals to -1, because top will be initially -1. That means nothing is going to be there inside the whole array, which means the stack is right now empty. Next up, in the same class stack only, remember, we are going to start using void push. Okay, this is going to be our first function inside the class. Okay, void push, and in this case I can have a variable int x, which is going to be our parameter. In this case, what happens is that, as I told you, I can check for the overflow condition. I cannot push any more further if the array is already full. That means if arr, so I'll tell, if I can say here, if top is equals to n minus 1, in that scenario we can just say cout, and I can print stack overflown. Okay, and end L, which is going to allow us to stop the execution. I can just say return empty. Remember, it is void type of function, so I can say return a void space, which will not do anything but just make sure that the function is over. So no push can be done in that case by printing the stack is overflown. Okay. Next up, this was the overflown condition. The next thing is going to be top plus plus, as I have explained this, top plus plus, and then arr of top equals to x in this case, and hence you can do the push. Also, don't forget that class always ends with a semicolon in this case, right? This is gonna be your void push. I hope so that this is very much clear. Very easy. We are just saying that this is gonna be it, push int x, if top is equals to -1, then it is overflown, return, otherwise top plus plus arr of top equals to x. This is a very easy one. Alright, next, what we are going to do is, the next operation is going to be void pop. I am going to say void pop. How do I do void pop then? I will say void pop. Now I'll have to check for underflow condition, and to check for underflow condition, what is the condition? If top is gonna be equals to -1, in that case Cout, I can say stack underflown, no elements to pop. Alright, in this case Cout stack underflown, no elements to pop. Okay, and then after this you just say return empty, and at last I can say here top minus, hence decrementing the value, and pop is done, already done. I hope so that this is very much clear. So in this case this is gonna be the pop example, pop function. Alright, this is gonna be the pop function. Alright, next up, the third function which we are going to talk about is going to be the top. Top is going to return me the topmost value of the array. That means the value which is going to get deleted next, or the latest value which is going to come out first if I say pop, and that is going to be top function in this case. Because it is going to return me a value, the return type of this function is going to be int, and I am going to not say top because top is a variable in this case. So I am going to start this top as top, top T capital. This is a function, while normal T small is the variable in this case. So I said top, this is gonna return me a value, the topmost value, and hence this is gonna be integer in this case. So now I said if top, because you see if there is no elements to pop, there can be no top will be -1. In that case it will again use the same condition for underflow. So I say top is equals to -1. In that case you say Cout no elements in the stack is present. Okay, I hope so that this is very much clear. End L. Okay, now in this case what we will say return, but I cannot just leave it empty like this. In this case I will say return -1 because it is returning an integer value, so I need to return a negative value in this case at least. So I will say here -1. Okay, this is gonna be the top in this case. I hope so that this is very much clear. Next up is gonna be, oh, one more thing, I have not written the actual condition for the top. So in this case I will say return what? ARR of top. In this case I am using the array notation to return the value stored at that particular top. So whatever the top will be, that particular value using that index, ARR of that index is gonna be returning me that particular value for that element. I hope so that this is very much clear. Okay, all right. Next up, the last function that we are going to talk about is going to be bool empty. As we have discussed that we are going to do the last one here. In this case it is very simple. I am going to return this value, return top equals to -1. Now I have written it in very short. What this is going to do is that it is going to just return top is equals to -1. In this case it is going to return the bool value. So if this condition is true at that time, that means if really top is equals to -1, it will return true out of this function, and if this is not going to be -1, in that case it will return false. So it is very simple and it can be done in just one line. Danger Maheshwari, good evening sir, good evening. Came late, we are about to finish the concept, but so these are the 4 functions that we have written in this case. So in this case we have written 4 things: push, pop, top and empty. I hope so that this is very much clear. Using object oriented programming in C++. I have created a class stack array pointer, use that array pointer to allocate the memory using the constructor of that class, and I have said that these are the 4 functions that we have done. I hope so that this is very much clear. Okay. Next up, let me start with the execution. To do the execution, we need to create our main in this case, right? So int main, don't forget that, int main. Okay. Sir, I am using DSA using Java, is it good? Yes, you can do that. You can do that, definitely you can do that. DSA can be done in any language. You can do that in Python also, you can do that in C also. Whichever language you are comfortable with, you can do that in that particular language. You can do DSA in that particular language. Just make sure that you are confident in Java so that you can handle any type of this questions. Sir, I know array, linked list, stack, use binary trees, but still curious about your video. Oh, thank you so much. Actually, I am starting doing DSA from the scratch. Today is the first day actually where we are learning about stack data structure, and later on we will learn a lot more things like stacks, queues, linked list. We will talk about trees, we talk about graphs, all of that we will talk about, but in this live session I am using C++. So if you want to learn that in C++ also, you can just come into my live session and you can do this. Anyways, we are about to finish the class. So in this case, we are gonna just create our main function, and finally we will end up this class, do the execution also. So let me just finish up the execution quickly. In this case, what is gonna happen in this case is gonna be, you see that we are having a class stack and all the functions are kept inside this class stack. So what happens is that I can just create a object of that class and then use that object to create functions. So in this case, what I am saying is gonna be calling the stack object. So stack, I would say stack, and then I will say, let's say create an object called as st maybe, alright. Using that I can say st dot, I can call push. Let's take the same example. I'll say push, I'll say 5. I'll push the first element, okay. I'll say st dot push, I'll say 10. I'll push 10 also. I'll say st dot push, I'll say 15. Okay. I'll say 15. Let's say I have done the 3. Okay. Next up, I will pop. Now pop will not return me a value, so I need to print it also. So what I'll do is, I'll first say cout. I will say top will return me the value, so I'll say st dot top. This function is gonna get called and that is gonna be returned. So if I say the topmost element is 15, will this print 15? Let's check. Yes, it is printing 15. That means we are doing absolutely correct job. In this case, now I will say st dot pop. When I say st dot pop, that 15 will get popped off and the next top is gonna be 10. So if I copy and paste it here right after this, what happens is that the next top is gonna be 10. I hope so that this is very much clear. Alright. Now if I again say st dot pop, what happens? That this 10 is also popped. So now 5 is at the top. So if I just print this top again, in that case we will print this 5. And now one more, if I say pop, st dot pop, you can see that now it should print, it is underflown and it should return -1. In this case nothing happened, but I will say multiple times pop, okay, because now 5 has been popped. So if I say multiple times popped, it should tell us stack underflows, no element to pop. See, 2 times I have done the pop, so it has been gone to underflow 2 times in this case. I hope so that this is very much clear. Okay. Now we will never met the overflow condition because the size of my array is gonna be 100, because in the macro substitution preprocessor directive I have kept the value as 100. So 100 values I can push inside this array, not more than that. But if I reduce, I can reach the overflow condition as well. But I hope so that you've got the point from today's class, that this is how the stack is gonna be used, and we can work around with the stack like this. This is your user defined stack, where today we have done object oriented programming, implemented object oriented programming, and using that object oriented programming I have explained how you can implement a stack using arrays and array pointer, using dynamic memory allocation, and all of that in one place. Well, I hope so that this is very much clear. This was a stack, guys, and this is just the array implementation. In upcoming classes we will be talking about different variations of creation of stacks from multiple different sources. This was just the first program and the first concept for the day 1, that is the stack. This is very basics, and today what we have done is gonna be the user defined stack version of it. In the next class I will be doing queues. In tomorrow's class I will be doing queues, but the same kind of a concept where I am used this stacks. Today's class stack was done. Tomorrow's class I will take up with queues, and the same thing what I have done right now today gonna be doing tomorrow also with the queues data structure. Then I will come to linked list, and when I finish up linked list I will come back to stacks and queues and do both stacks and queues with linked list, and then we will move on to trees. So this will be done every day, 1 hour class session we will have, and I will cover up all your C++ and data structures also with everything which is gonna be asked in interview. So trust the process, stay tuned till the end of the course, and every day keep learning. You will learn something or the other thing new in our live streams. So don't forget to like, share and subscribe also. And thank you so much for watching today's live stream, and rest of that, if you have missed anything from any of our live streams, then I have already created the playlist, and I have already put up all the previous sessions of all the lives that we have went in the past. From past 4 days I am doing this live, and all the 4 sessions I was just doing DSA prerequisite. I explained what is DSA, I have explained all the prerequisites, I have explained pointers, dynamic memory allocation, all of that I have already done, which is already recorded and stored in our playlist. So if you have missed that, please go ahead and watch that. And this was today's session. Thank you so much for watching. I will see you next, that is tomorrow, same time at 6 o'clock in the evening, and we will continue with queues data structure. If you have any doubts, please ask me in the chat or in the comment section below. I will try to solve your doubts as soon as possible. Also, I am doing machine learning. We are going to start that. So if you are interested in learning machine learning, stay tuned for it and subscribe to our channel for more updates like this. That's all. This is Ashank David signing off. I will see you guys in the next video. Till then, take care and bye bye.